All right, let's help you out with how to make a graph of your data in Excel. So take a look at how I have three different tabs at the bottom. I have trials 1 and 2. Perhaps you have 3 trials, perhaps you have only 1 trial. Hopefully you still have some organization of your data similar to mine, where I've got my lowest CO2, medium CO2, and highest CO2. First thing I'm going to do is I'm going to get an average of my trials for each of those 3 scenarios. And so I'm going to click on the cell next to trial 1 and 2 and enter an equal sign and start typing average. And then I'm going to type a parenthesis. You can see it up in this box right here. And highlight those 2 trials and do a closed parenthesis and hit enter. Now here's the fancy trick. If you click on a cell and you want to copy that formula to a bunch of other cells, you can click on the lower right and your little cursor becomes a cross, and you can click on it and drag it down as far as you want to. Now we were supposed to collect data for 50 seconds, so I'm going to just drag it down to the 50. Now I'm going to do the exact same thing in my medium CO2 as well as my highest CO2. So I'm going to go a little bit faster on these 2. It'll give you great practice. Average equals average, parentheses, close parenthesis. All right. So in a moment here, I'm going to have all 3 averages of my data. But now I need to actually get this together so that I can easily graph it. There's more than one way to do this. I'm just going to call this a new sheet, combined data with my averages. And it doesn't matter which one I pull from, but I'm going to go ahead and grab the time data. And I'm just going to label this time in seconds. And then I'm going to click on each of the tabs, and this is tricky a little bit. I'm going to grab all this data, and I'm going to hit Control-C, and it gets a little messed up since it has a formula. I'm going to right-click and find the paste option with the numbers. It says values, and click on that. Otherwise, it starts trying to average it with the time, and it's just not correct. So I'm going to do the same thing with my data from my medium and my high. I'm going to grab those times, and I'm going to right-click. Oops, apparently I didn't copy it from here. So I'm going to go back, Control-C, right-click, copy the values. Go back to my highest, Control-C, right-click. Oops. Maybe I just need to go back and grab it again each time. Control-C, right-click, paste the values. There we go. And I'm going to relabel these lowest CO2, medium CO2, and highest CO2. All that work, and now I'm ready to insert my graph. So I'm going to highlight all of my data and insert a scatter plot. So look at all these charts, the one with just the dots, but then adding lines. So I'm going to click on that. And the next thing I like to do is click on the quick layout up here in the upper left. And I'm going to choose the first one here. This one gives me the ability to easily insert a title as well as the axis titles. And I definitely don't like the colors, so I'll show you how to change those too. So add your own title, something like time versus temperature with varying CO2 concentrations. Little pro tip, if you highlight a number that you want to make subscript and right click it, you can click on font, and there's a box you can click in subscript and hit OK. Also going to label my other axes. We've got temperature in degrees Celsius. And going across the bottom, we have time that we were measuring in seconds. If I click on the axis and right click it, I can format it, and off to the right here, I don't need it to go to 60 seconds because we stopped the experiment at 50 seconds. So I'm going to change that. And I'm also going to change the other axis because we don't really need it to start at 0. We can spread out this data if we started at 20 and go to 35. And now let's mess with the colors. If I click on the data here, I can right click, format the data, and let's see, I'm going to change that solid line to be red, and the marker fill, I'm going to change that to be red, the border to be red, no more of that gray, everything is red. Not sure why there's so many things to change, but that looks good. And then I'm going to click on my next set of data. That can stay orange, and my lowest CO2, maybe I want to make this a brighter blue. I can change that as well. You can get creative here. Careful, it can be addicting. You could play for this for longer periods of time than you meant to. Okay, so we're looking good with our data here. Now let's add some trend lines. If I click on the top one and right click, add trend line, I can go to the bottom here and click display the equation on the chart. Move that around a little bit. I'm going to click on the second one and do the same thing, add a trend line, display the equation on the chart, move that around, and click on the bottom one, add trend line, display the equation on the chart. Now take a look at these slopes. The bottom one, the slope is 0.14. The middle one is 0.19, and the top one is 0.20. So as the CO2 levels were increased, the faster the temperature changes over time. So going back to our questions here, what does the slope of these lines represent? We can say something like the slope represents the rate at which the temperature increases over time. If you continue to run your experiment for 30 minutes rather than a minute, do you think the slope of your lines would change? So that's up to you. That's just a hypothesis question. Heat exhaustion is more likely when the temperature is 38 degrees Celsius or higher. Did any of your scenarios reach 38 degrees Celsius? So if we look back at our data, the highest got about 33 degrees Celsius. So no. It says, if no, what could you have changed about your experiment to cause that temperature to go up to 38 degrees Celsius? And then this is the one people were asking me about. Use the equation from the scenario with the largest slope. So if we go back, we can see the equation for the top line was 0.205x plus 22.822. So if I put a 0 in here times 0, that means my initial temperature was 22.822 degrees Celsius. But what this question is asking us is, at what time would we need to enter here for it to reach 38 degrees Celsius? So we're going to plug in 38 degrees Celsius and do a little algebra. So I can subtract the 22.822 from both sides. And then I come up with a new equation. 15.178 is equal to 0.205x. Divide both sides by 0.205. And then I'm going to have x by itself around 74 seconds. So our experiment stopped at 50 seconds, but if we had kept it going, we would predict that around 74 seconds, we would hit that 38 degrees Celsius. And the rest of it is really about making a claim, providing some evidence, and thinking about the reasoning to explain your claim as you look at your results from this experiment. So good luck finishing the rest of these questions here, including all of the making sense questions.